All right, the box for today is going to be hacked. It's a two-part box, really interesting concept where you do some analysis on a PCAP and then use the analysis that you find to actually access the box and finish out the rest of the room. So let's look at this room here. Um, it's it's more of again a question type room, a challenge type room. This one has two parts. Like I said, you download task files, which you'll use to answer these questions. And then the second part is going to be where you hack in using that information also. So it should be a really cool room. So we'll start off by downloading the task files. And we'll go ahead and move those into our current directory. All right. And so we could do several different things on this PCAP to kind of know more about it. Majority of the time, you use Wireshark. It just provides a good graphical interface for that to do that. So we'll go ahead and complete that task, and then let's go ahead and load it up in Wireshark. You can run Wireshark from the command if you want, and tell it to read in that PCAP file. We see here's some things. So if you've never done analysis on PCAPs before, some of the big things to kind of look at is first, you want to look at your statistics and then look at like conversations. So this tells you what you're seeing here is the systems on the left-hand side use these ports to talk to the systems on the right-hand side using these ports, and then how many bytes that was. And that can be a good indication of lots of data being transferred back and forth, or just little commands here and there. So things that immediately jump out is like the 6,000 bytes right here, followed by the 3,000, and then these look like they're small type of commands or data going back and forth. So we'll definitely look at that when we dive in there. Some other things that you can look at is the protocol hierarchy. So this will give you a high level of number of bytes and packets that were present in this capture. So in this capture, we only have two, HTTP and FTP. But on a bigger capture, you could have multiples, and that would give you the ability to kind of see um, if there's other types of protocols running and what they are. And I want to say, so IO graphs there kind of gives you a peek, so you can see when something, maybe had a lot of traffic or big indication of something happening there. All right. So let's dive in there. Another things that you can do is you can also query specific things and pull stuff out of Wireshark. Like if there was files transferred or anything like that, you could have that pulled out. All right. So the first question is the attacker is trying to log into a specific service. What service is this? Okay. So based on the numbers here, we can see that we have either HTTP or FTP data. So we're going to go with FTP because that's the only 3-letter word. So again, I based that just off of the ports and what we saw there. And we, again, got that from statistics and then conversations here. So again, those are the ports that it was talking to. Very popular tool by von Hauser, which can be used to brute force a series of services. What is this name of this tool? So this one you'll have to do some Googling on this one. Nothing's jumping out to mind. Let's see if we can. Oh, Hydra. Yep. I had an inkling that it was going to be Hydra, but there we go. So now they're asking for more details, like what the attacker is trying to log on with a specific username. What is that username? So now we actually need to look into this data and see. So in Wireshark, each one of these are like a packet, and so that goes back and forth between the systems. So send is me sending it to there, and you can see the direction. Majority of the time, it's just going to show it from left to right, basically. So you're not going to see, this arrow going back the other way. But the way you can kind of look at this is the host that tried to talk to this host, and they used this port to that port. And then in TCP, knowing and understanding how TCP works and talks, then you can see the complete connection there. So a SYN is the first part of the TCP connection, and then a SYN ACK is the response. So you can see that this port talked back to 64, which is the top one there. And we also can confirm that because the source IP is the same as the destination IP, and the destination IP is the same as the source. So that makes sense. And then what we see is the next one is the acknowledgement of that packet back to, flipping it basically. And so that completes the TCP handshake. Or sometimes you have a 4-part handshake where this would be another SYN-ACK. But in this case, they're just following the regular. So we have valid connection here. And we can see that there's definitely back and forth connections. There's a lot of ACKs here. All right, and then when we look into getting more into the data, then we actually eventually see the FTP. And so if we want to just filter on FTP, the display bar up here allows you to do that. So we can type in FTP, and that will only show us just the FTP data. Now, in order to see more information, you have a little different parts of Wireshark here. So you have the actual packet, and so we're right now looking at packet 49. And then it breaks it down by the sections of the packet. So you can get down to the frame, the Ethernet, Internet Protocol, TCP, FTP, and then you'll see the actual data inside the packet. And each one of these numbers here and hex addresses actually relate back up to here. So if like I was to point out frame number, let's see here. Pick a section that's actually going to do something. There we go. So this is the actual destination portion of the packet in hex. And if we click on the next one, you'll see that's the next part. And you can kind of see that throughout. Now this one here is not highlighting all of it like the 92A to AF like it should. But that's all part of it. And then the next portion there tells you that it's IP4. And then you can see here's the header link. So if you get really good, what you'll do is you could really just read this hex and kind of tell where things are at eventually and what it is. Because there's been known attacks in Wireshark. So again, Wireshark's a tool, right? And it reads this data and then it does an interpretation of it. And so that doesn't mean that's the hard fact of what that is. You sometimes have to look at that actual data raw and see if that's what it actually, if it did the interpretation correctly. So, anyways, so we have an idea, right? And now we're able to see wherever the data is at for FTP. So we need to kind of see what username. And if we scroll down, then we can start seeing where we make a request here, and we see it looks like Jenny. Jenny's the one there, and then it's going to try multiple passwords. So we see user Jenny is pretty much the one used. We did eventually get a login successful, so it would be good to follow this part of the packets and see what password got them in. Okay, so from that information, we are able to determine that Jenny is going to be it. And like I said, the next one is, of course, password. So let's go back to the message where we found the correct password, login successful. And if you right-click on this, and you can then do follow and TCP stream. So again, a TCP stream is the connections back and forth, and all this is doing is decoding that data that we saw in the bottom there, and finding packets that relate to each other, that are tied to each other. And so there we go. So that's stream 7. We can see here. And I'm going to minimize this, and I'm going to show you the stream. So this is the whole stream of that whole connection, basically. So we see here, there's the SYN, there's the SYN ACK back, then we got another ACK, then we got a response from FTP, and then they tried Jenny, and then it said, give a password. It first tried all ones, and that was incorrect, and so on and so forth. So we can see each time, it's trying the different passwords, and then there was a login successful. And then you'll see here that it sent a FINAC, which is a finish acknowledgement, and the server basically sent that back. All right, so let's bring back up that window there, and that's going to be the one. What is the current FTP working directory after the attacker's logged in? So again, we're looking at FTP information here, and so we're still evaluating TCP stream equals 7. And what we want to do is we're going to have to clear that out, but we want to note what packet we're on. So it was asking after the attacker logged in, right? And so the attacker logged in successfully on packet 305. That's where it says it. So up here, if you click the X, that's going to clear the display, and that's going to remove all the filters, and we're going to see everything again. And so we need to kind of look to see after 307 what directory did they go into. So we still see a couple login incorrects here. And that's probably it finishing up, trying to brute force into the system. Now we're looking at TCP packets again. This is the fins, all the fin ACKs being sent from, looks like the scanner to the server so that it closes the connections. Okay, so again, we see our attacker logging back in again, right here. And so then now we should see where we're at. So this is where they requested SYST. There's print working directory, and there's our answer right there. So again, there's the FTP. The request was PWD. And if we look into this here, right, let's minimize some of these other portions of the packet. That's the request command there. And that's just telling you the current working directory. So then the next one, of course, is the response. And the response actually has its own special codes and stuff like that that tell you, things so that it knows how to interpret it. So we're in var www HTML. So let's enter that out. All right. So now the attacker uploaded a backdoor. What's the backdoor's file name? And so this is big in incident response. Having these clear text protocols in use, or if you do SSL, termination and then capture from there, that's great too. So then you would be able to see some of this type of stuff. So it looks like he's going to list out the files. There's the initial response back, so we can see that there's index.html. And notice that we've switched over to the FTP data port here. So that's a different port. That's on port 20. So usually the indication that they're about to upload or do something, sometimes, or look at more data, is switching into binary mode. And there we go. We can see what they're doing right there. So that's usually a big indication. And shell.php. So this is saying that backdoor can be downloaded from a specific URL and it's located inside the upload file. What is that full URL? Okay, so there we go. So what you wouldn't see in there and what we were kind of going past is there's a couple commands, before it needs to, store the data that you're about to send it. So, basically it's kind of like creating the empty file on the file system, and that's what the store request is going to do, and then it's responding back and saying, okay, go ahead and send the data. I'm ready for you now. I've created a buffer. I'm ready to receive this data. And then that's what the next one is that we're actually sending the data. So there's the URL portion of that. Again, we can also follow this conversation, TCP stream, see the whole thing. All right. So now we're looking into seeing what the attacker did after they got the reverse shell. So now we have a PHP shell uploaded, and if you've done that before, you're not going to see anything else on the FTP section or side here because we already uploaded it. We now have this web service available to us, and so the next connection that we need to be looking for after this now is that port 80 calling to shell.php. So let's see if we can find anything. So we can see that they gave the permissions to the shell. That was via FTP, and then they quit, right? All right, so then lo and behold, next connection is to port 80. There's the get shell PHP. All right, and this looks like that's going to be, we got some information back there. There's the login. So we're getting information back and forth. Let's see if we can follow this and make sense of it. So there's the HTML. Another thing we can also do is go to stream 20. So now we're just following the streams and seeing what we get. So we're not seeing the first command being ran here. But based on this banner, that's usually uname. Let's see if that works. Okay. Let's then do what they actually wrote in, which is who am I? There you go. Computer's host name. So it looks like our host name is going to be WIR3. What command did the attacker execute to spawn a new TTY shell? So they did the tried and true Python 3. Okay, which command was executed to gain a root shell? So it looks like they just did a sudo. They were part of the sudo orgs group. What's the name of the GitHub project? Project is used to install a stealthy backdoor in the system. It can be hard to detect. What type of backdoor is this called? So for that, we'll have to look at the actual repo and see what this is. So they're calling it a rootkit. All right. So now we need to deploy the machine. The attacker has changed the user's password. Can you replicate the attacker's steps and read the flag.txt? All right, so the attacker's steps, again, from before is that they brute forced Ginny's password and got in that way. And then they just did a sudo. So we could try Jenny's password and just see. There's also potentially shell.php still uploaded, so we could run that. So let's see what this system has to offer. All right, let's open up a new window here. Or go ahead and just run an mmap just to confirm open ports and stuff like that. We're going to do open. Let's do service version. See if anything comes back. Okay, it does say it's open or up, but didn't come back with any ports or anything. So we'll just do all ports real quick. All that scanning, let's go ahead and go to the website too and just confirm. Okay, we do get the default page. Again, the attacker did upload something to shell.php. So let's see if that's still available. So it doesn't look like the shell.php is still there. No, that's interesting. Failed to daemonize. But it actually still might be there. Let's go ahead and try the FTP for it while we're waiting. Might be still booting up or something. Definitely seems very slow. Yeah, so this is kind of guiding us in that right direction. All right, so we are getting the service back up, so that's good there. All right, so as the room's kind of pointing out, let's go ahead and use Hydra. We did get our services finally up. So we'll do Hydra -L is going to be Ginny, -P is going to be our word list, and that's going to be in user share word list. Let's just do the standard RockU, and then that's going to be FTP / and copy the IP address. So again, similarly, if we were capturing Wireshark data, we would see the same thing that we saw in the packet analysis there. We could do, let's do, there it goes, TCP dump -I ton 0, and then let's do that one more time, just so you can kind of maybe see that. So that's what you're seeing right there. That's TCP data, uh, you know, being basically dumped onto the console. So we could write that to a file with a -W, and that would be the same thing that we evaluated with Wireshark there. And so that's you're seeing the same exact thing that we saw on Wireshark, just in a console format there. So we see the port, or the IP, the port, and what it's calling to, and then the flags. And so we can see here, similar to earlier, where we have login incorrect. What the response basically was is, one of those was login correct, and then that tells Hydra, hey, that's the password. And Hydra says, okay, thanks for that. So now we have it. We have the password there. But I just wanted to give you the background and let you, so you could see that. See, there's the login successful. Now again, that's to kind of highlight this. Looking at it on the console might give you the false assumption that it was Junior. Um, if you remember back to when we looked at the packet capture, you kind of had to go and find the packet that actually mattered to. So these sequencing numbers tell you different spots of where packets kind of align to each other, or part of each other, and so you'd have to follow the sequence number to kind of get back to the one where it was this password here. So we'll log in there and we'll upload a shell. So let me clear out both of these terminals. So we can close this up here. We'll clear that out. We can go ahead and exit that, and we'll go back up and clear. And now we'll do FTP, and that's going to be there. It's going to be Jenny, and then we're going to paste the password. So same thing, if we look at ls, so the shell.php is still there, which is interesting. I'm going to guess that the shell PHP is well, it is the reverse callback. So that's why it didn't want to work earlier. It's because we're calling it and it's trying to call back to another server, not our server. Um, we could change it to a bind shell, or and that would work too. All right, so they were using for the reverse shell the Pentest Monkey PHP one. We could use that. We could also use Metasploit if we wanted to. Um, let's see if there's anything that really matters. Yeah, either way, it doesn't matter. Just to save time and stuff, we'll use the Pentest Monkey. So we need to find that one. Again, in in Kali, you can do web shells as a command, and it'll automatically take you to the directory of the common web shells. And so it breaks it down the directories that are available: ASP, ASP.next, CFM, JSP, Perl, and PHP. We care about PHP, so we're going to go into PHP, and then we're going to look at that, and we'll see the PHP reverse shell. So let's copy PHP rev shell, and then let's put it into our hacked directory. Okay, so that should be over there now. And so if we cd into that directory, we should have that shell. And let's open it up. So I have Visual Studio Code on there. So if I type in code and then the file, it'll open up in Visual Studio Code. All right. The parts that we care about are right here, the IP and the port number. So let's change these. Let's change this to 5555, and then the IP address is going to be R1001. So when you're logged into TryHackMe, it'll put it up on the top here. So it should be here. So 10.2.12. Yours will be, of course, different. So make sure you do that. Yeah, so this is why I put uname first, because that is the first command that gets executed whenever the shell logs in. It just whoever made the room didn't take that into account, that understanding what your tools. All right, so we'll do that. On top of that too, I'm just gonna go ahead and put bin bash because I like bin bash. All right, we have the file there. We can close Studio now. I saved it, so once we close that, we'll clear this up. And what we're gonna do is upload that and call it something different. So it's gonna call PHP reverse shell.php. Copy. And then upload that. It's put. There we go. So if we now look up there, we should see that. Okay. Before we execute the PHP, we need to have our listener going. So netcat listening very verbosely on port 55555 or 5555. That should be good. There we go. And now when we go here, we'll now call that file. And that should get us. Oh, we did not make it executable or do any of the other stuff, so that is our issue. So chmod. There we go. And now if we run this, so again, we're making that executable so that it can do, it can actually run. All right, so now we're in. We got our shell back here, www data or3. Let's look at our task on TryHackMe and see if we need to answer anything or how we're doing. Okay, so we completed that. We did that one. We created a listener. Okay, and now we're about to become root. And then we just need to find the flag.txt. Okay. So based on what we saw before, right, they just did sudo su. And I'm going to bring this box up more. All right, so interesting enough, it asks there's no TTY present and no ASP program specified. So what's happening is sudo is asking for a way for the password, and because we can't provide that, right, it can't do it. So we need to do the PTY trick here to give that to it. So that's the Python. And if you don't remember where that's at, that's right here. And so that's why you saw the person do that when they were in the system. Okay. So it's asking us for www data, which we do not have. So what we need to do is actually switch users to Ginny because we have Ginny's password. So we're just going to push this 3 times. It's going to exit out of that, and we're going to switch users to Ginny. And that's going to be the password that we had before. There we go. So now we're in Ginny, and that doesn't work, of course, but we can do, and that's going to be the same password. And there we are. We're root now. Okay. And to finish out the box, we need to look at that directory. So ls, it was read the flag.txt inside the reptile directory. Okay, so this said, all right, where's the reptile directory? All right, so let's look in root. There's the reptile directory. And then there's the flag. Sorry, have it keep doing tab completion and it's not there. So again, pretty cool, pretty easy little box. You get to do analysis on someone that owned it before. I've seen this sometimes in like little tests for if you're applying for an incident handling job. They want you to kind of review that a little bit and then see what happened and be able to replay the attack. I think that's a cool idea, um, cool little trick to kind of just make sure people are able to look at something and go from there. And then it gives you the ability to kind of still follow the attacker's footsteps and see what happened and how that went. So I hope you learned something out of the box. Again, the bigger part of this and the more information is in the Wireshark and understanding how to read the packet captures and get the data out of that. And um, it just takes time and it takes a lot of going through. Additional things that we've could have also used with this for packet captures, just to kind of give you a little bit more context. Let's close that. That's fine. We don't need that anymore. So we have this, and we can do ngrep, and we can put input a file, right? And that's going to be this capture. And then what we are doing here is just like any other grep, we can search for strings or things like that. So we could look for shell. So anytime shell showed up, there's the name, there's the packet number. So you get a big hit on that. You could have an idea where to search then. So we can see the store shell.php. There's the PHP shell. Another good one if you're doing quick analysis on things is if you do depending on like if you're using Linux or the host system was Linux, if you search for Linux, then that kind of usually print out the banner, and so then that that's a good indication that something got compromised. Same thing with like root or any of the users on the box. Again, with this being clear text, we're able to read all this data inside, and so you can kind of see where that's at. And we can also see here where they made that root directory reptile user LAN. So it's a good way,